Good morning, everyone. Okay, we will be working with um, permutations today, so we are continuing on in our probability unit. And so you need to go to page 2H in your packet. Sorry. Um, we will continue. I'll repeat that. We're continuing on our permutation, so it's our probability package, which we're continuing in. So these notes are on permutation. And so you'll need to go to 2H in your packet because that's where we're going to be. So it's at the very back. It's a little bit out of order. So let's go ahead and get started and let's bring up those notes and we can move on from there. Okay, so if you page over. And again, we are doing some skipping around. And it looks like it's in a different spot. So give me just a moment. All right, thank you for waiting. So again, this is on page 2H, and so that's where you should be joining me right now. And so what we're looking at here is we're just going to fill in with where we are. Let's make this let's use a little bit of a different color so maybe it'll stand out a little bit. And so therefore we're looking at a permutation. And let's get on my pen. A permutation, as you can see, is an arrangement of objects in a specific order. When the objects are arranged in the row, I believe the permutation is called linear. I'll double check on that. I was trying to check. Okay, so what you're looking at is our first example would be how many different arrangements are there for the letters A, B, C, and D. So if we go to the next slide, you'll see that there's a table there. Okay, one of the big things you should remember about permutations is that the order does matter. And so what we're going to do is we're going to fill in this chart. So I'm going to do A, B, C, D. And then I think from my next one, I'm going to do A, C, B, D. And then I'm going to do A, C, D, B. And then I'm going to do A, B, D, C. All right. And so now I think I've done all the combinations that have that. And you know what? Let's put them here because I think that's how this is working. And there's nothing special about this. I just want to make sure I have every possible choice. And so I'm going to take my eraser and I'm going to erase these right here. Now let's do another one. So instead of A being first, let's let B be first. And so B, A, C, D. And then let's do B, A, D, C. And then let's do B, C, A, D. And then let's do B, C, D, A. And then let's do, and I haven't done it here, so let's do AD and then BD. And so what you're going to do is you're going to make up all these. And if you notice, there are 24 boxes here. So if you fill in every possible combination, you are looking at 24 different permutations. Therefore, there are 24 possible arrangements that we can use. All right. And now, the way that we write this is we are going to use a symbol called factorial. So I'm going to go ahead and go to the next slide. And so you see that we have a factorial notation to abbreviate this product. And so for an example, if you have 4 factorial, it's 4 times 3 times 2 times 1, which gives you 12 times 2, so it's 24. Notice if you go back to the previous screen, there were 4 letters we were looking at. And so by doing 4 factorial, that's how we got that. And you should also know that when you have 0 factorial, it's always 1. So if you want to find the number of permutations of n objects, it is given by n factorial. Now, on your calculators, there is a way to find n factorial. For most of the calculators, hold on just a second, it's usually a button that's right on your calculator. For some of you, it's like above one of the keys. Looking at some of these, I know on the Casio, if you're looking at your Casio, if you hit option and then arrow over and go to probability, that's where you find factorial permutations and combinations. And so if you have any questions, you can just ask me personally about your particular calculator, and then I can help you see that. All right. So that'll start to save you because at first it's not bad, but when the numbers get bigger, you're not going to want to do that. So our example here is that there are 9 players. and the starting lineup on a baseball team. So before the game, the manager announces the order they will bat. So how many different orders are possible? So how many objects or how many players are there? There's 9. So we're looking at 9. I don't like how that color looks. Sorry. Let's do blue. I want something a little brighter. So we're looking at 9 factorial. So that's 9 times 8. I changed it up. Times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so the shortcut way again is to use the factorial key. And so I'm going to do that real quick because I know where mine is. And again, like I said, if you need help, please let me know. And then I'm going to put the factorial there. And what you end up getting is you get that it's 362,880. All right, so that's how you work that. And again, please ask me about finding your factorial key on your calculator. They all have them, so it's not a problem. Okay, so now going to the next one, what we're looking at here is we're looking at the permutations of objects taken R at a time. So in this particular case, like the number of ways you can arrange 11 things taken 8 at a time. And so it's when you're not using the whole thing. The other one is you're using every single possibility. Okay, and so how you write it is P11, permutation of 11 taken 8 at a time. And so that NR is read, the permutations of N objects taken R at a time. And then this is how it's written. Now, one of the things you need to pay attention to, and I'm going to do this one in red, because this is how it looks on your calculator. And so the way you would plug this in on your calculator is, this is the formula to do it, okay? But here you would put N, so N would be 11, and then you would P, hit the button, and then you're going to hit 8, which is R. And so I'm probably going to show everybody this at the beginning, and then that way you can jump right into it. And keep in mind, R has to be less than or equal to N. And so N is your number of items, and R is how many times it's taking. So our example here is going to be, we want 5 CDs out of a selection of 15. So we want to have 15 items taken 5 at a time. So N is 15 and R is 5. Excuse that, I'm near the restroom. All right, and so what we want to write is we're going to write 15PR. And so the way you're going to show that, you can fill in the formula if you need to. So you're going to do 15 factorial over 15, whoops, I didn't mean to write R, I meant to write 5. Okay, so minus 5 and then factorial. So a couple of different ways you can do that, but when you do that, you should get 360,360. Now, it really does, you should really try to make sure you've got this, because this is not very difficult to do, but I do want to make sure that you have this. All right, and so there's an example of that, and then we have a few more examples that we're going to do. But let's go on to the next slide. All right, and so we have permutations with identical objects, and so you have here the number of permutations of which P are alike and Q are different, and they have N and P and Q. This particular one is, notice that you're just doing the repeats. And so you literally can have several things across the bottom. So that's what they mean when they say the rule can be extended. You can have several objects that repeat. One of the ones that I've seen lots of people do would be Mississippi, where we do words because, okay, I gotta remember how to spell Mississippi. And if you remember the little song, crooked letter I, crooked letter I, humpback I. That's how I was like, because I couldn't remember how to spell it. So notice when you look at this, how many letters are in Mississippi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters, so that's my N in Mississippi. Now over that, which letters repeat? Well, I repeats 4 times, so there you go. All right, and then S repeats 4 times. There you go. But P only repeats twice. Now we don't need to do M because M doesn't repeat. Now if you're plugging this in on the calculator, one of the things I do recommend that you do is when you do this, put in the bottom in parentheses. And so when you do that, you have 11 and then factorial. And then I'm actually going to use my fraction key. If you have a Casio, I can show you how to do this. And so I'm going to put this in real quick. And then when I do that for Mississippi, I get there are 34,650 possible combinations because you're accounting for the identical objects. So here we have another example, which also happens to be 11. So 11 flowers and then the ones that repeat, okay? And so what you want to do is you want to do 11 factorial over 4 factorial, 5 factorial, 2 factorial. When you do that and you get it all in, you're going to get 6,930 ways she can that says she, should be he, can plant the flowers. Okay? So moving on to the next slide, we are going to go circular permutation. So this is where you arrange them in a circle. An example of this would be a bracelet, because our charm bracelet, because you know a lot of people have several charms, but it's in a circle. And so all you do is you take the number of distinct objects and you just subtract one and you do factorial. So here we have 7 appetizers on a circular tray. So we're going to do 7 minus 1 factorial. So that's basically 6 factorial, and then you just plug in your 6 and your factorial, and that's going to give you 720 possible combinations. All right? So pretty basic, pretty simple there. We're going to, like I said, work on these. And so then what I'd like to do is we're going to look at these, okay? And so here you have a permutation. Now, another thing I wanted to show you is I actually used the formula on some of these. And so what I did is I had 9p4, and when you do that, you should get 3024, okay? Here they did one with the words, so it's the permutations of all the letters in the words committee. All right? Now, keep in mind, if you were just of all the letters, you have to pay attention to whether are you taking care of the repeats or not. So let's go back. And if you look at permutations with identical objects, so we want to do that. All right. So then we're going to, go back. And so we're going to have 10 factorial over, let's see, the M repeats, and the T's repeat, and the E's repeat. Now keep in mind, put the bottom in parentheses. That's going to make a difference. So I'm going to do that one, and then I'm going to put it in, and then I'm going to do basically 2 times 2 times 2, okay, which is really 8. All right. And so what I'm going to get is I have 453,600. Now, if you just did 10 factorial, I'll be honest, you're going to get just over 3.5 million. So you need to pay attention to that. Now, here's another one where you're taking a group of 12. So 12 taken 3 at a time because you want 3 office holders. And so we're going to do 12p of 3. And on that, we're going to get 1320. And then you have knights at a round table. So keep in mind, you're going to have 10 minus 1 factorial equals 9 factorial. And so 9 factorial will give you 362,880 ways that you can sit 10 knights at your round table. All right. And so I'm actually going to stop right there, and I will put combinations on a different one. So just kind of let you know, and it'll be very short. So thank you very much.